Now today I want to talk about the toggle flip-flop. Toggle flip-flop. We learned that the set reset flip-flop is a elementary memory element on digital devices like computer, and the toggle flip-flop is the basic counting element. As you see here in the schematic of toggle flip-flop, we have two inputs and only one output. What is this T which is written clock? This clock is our clock digital pulse. I will show you. And this signal is the clear signal or clear input. In the case of toggle, what is the meaning of toggle? Toggle is complement the previous value. For example, if Q is 0, toggle means that this 0 get 1. And if Q is 1, toggle means that 1 gets to 0. Toggle is the complement. The meaning of toggle is complement. Now, when we can complement the output using the T signal, using the clock pulse, which is given to the T input, and with setting clear to 0, we can toggle the output. Up to when? Up to C is set to 0. If I set the clear signal, this input, to the 1, if C is 1, the Q, the output, is set to 0 and remains at the 0 level, at the low level, as long as C remains in high level. It means that C remains in 1. Now look at here. Let's talk about the actually trust table of the toggle flip-flop. This is, as you see here, this is my clock pulse. According to the time change from 0, 1, 0, 1, 0, 1, 0, 1. The period is TC. As you see here, the frequency of this signal during the time doesn't change, and also the period. This is one period, and this clock pulse, I think if I write it for you, it can be better. This is the clock pulse. Now, if you look at here, we know that here is low level or 0. Here is 1, high level. If my pulse goes 1 to 0, it means that this pulse is in its downward edge. And if my pulse goes from 0 to 1 or change from 0 to 1, it means that this signal is in its upward edge. Now, this toggle flip-flop, this type of toggle flip-flop that we consider in this course is in the type of downward. So I determine the downward of digital clock pulse. Digital clock pulse. Now I said that I can change my output according to this pulse when clear signal is 0. Now I want to show you how the output of toggle flip-flop changes. Now let's draw the C or clear. Suppose that I have the C clock which is 0 up to here, and here goes up to 1, for example, I don't know, up to here, and then goes to 0. Now look at here, I want to know that how my output will change, how my Q is changed. Look at here. If transition signal clock pulse is in the 0 or high level, my Q is in the 0 level. Up to when, this is the Q, this is the clear. I look at the clear is 0. It means that I can change my output using transition signal. Now I reach to the downward edge of pulse. What happened here? My output, which is in the 0 level, will toggle, because my transition signal is in downward edge. Will toggle and stay in this level. Up to when? Again, my pulse comes to 0, then change to 1, up to my toggle reach again to its downward edge. What happened here? Again, because my pulse is in the downward edge, it means that my output again will toggle. Now, what is the meaning of toggle at this case? It means that 1 change to 0, again stay at 0 level. Up to when? Up to my transition signal again reach to downward edge. Again, at this edge, I will have toggle. And my output will be changed to 1. Now look at here. At this time, I set the clear. I set my this signal, this input, to the 1 to the 1. And I said that when my C is 1, Q set to 0 and remains at the 0 level as long as my C remains 1. What is the meaning of this sentence? This sentence is that because my clear signal is set to the 1, it means that immediately I will have 0 at the output. Up to when? Up to time that my clear signal again set to 0. After that, again, according to the downward edge of transition signal, I can have complement toggle in the output. Let's continue. One of the application of this toggle flip-flop, and also here in this table, you can find how the output in the next value will change according to the downward. This arrow represents the downward edge of toggle flip-flop. Okay, as an application, we can use this flip-flop for counting. Now here I want to show you how can we count from 0 up to 15. How can we count from 0 up to 15? Suppose that I have 4 bits, Q3, Q1, 2, Q1, and Q0. I want to count for 4 bits. For this reason, I need to have 4 toggle flip-flop. And I connect them in the cascade form. As you see here, the output of first flip-flop, which is called Q0, is the input of second flip-flop, and the output of the second flip-flop is the input of third flip-flop up to the end. And I set the clear signal of all of the flip-flops to the 0 because my flip-flop works at when the clear signal is set to 0. If clear signal is set to 1, I will have 0 always at the output. For this reason, I don't want to set it to the 1. I set it to the 0. Now, let's investigate this example, but I want to show you this example with 3 bits. With 3 bits. Q2, Q1, Q0. And I want to count from 0 up to 7 because using 3 bits, I only can count from 0 to 7. I only can count 8 numbers. I said that to reach this aim, I need to connect the flip-flops according to the numbers of bits. If I have 3 bits, it means that I will have 3 flip-flops, T, C, Q. Now I connect this output to this input. This is Q0. This output to this input, which is Q1, and this one is Q2. And I set all of the clears to the 0. Now, if I set this signal, for example, I called it A, like that. Look at here. Now, I set it to clock pulse. In the downward edge, flip-flop will work. And I need to know that how my outputs will change. Now, let's start with the Q0. If I set it to the A signal, my Q0 will change like that. I set that at the downward, my Q0 will change from 0 to 1. Again, at this downward, again, at this downward, at this downward. This Q0 is the output of the first. For example, if this is the first flip-flop, second flip-flop, third flip-flop. This output is Q0. Look at here. Now I want to have the output of the second flip-flop, Q1. I said that when I reach to the downward, I will toggle and stay at this state. Again, I reach to the toggle, to the downward toggle, downward toggle, downward toggle, reach to downward toggle, reach to downward toggle. Now, this signal, Q1 signal, is the input of the third flip-flop. I want to draw the Q2 pulse, Q2 signal. I said that and I learned that my output will change. Now, from here up to here, my Q2 will be stay at 0 state. When Q1 reaches to its downward edge, Q1 here is here. Q1 is the transition signal of third flip-flop. It means that Q2 will change according to Q1. Now I am in the transition edge of Q1. It means that my Q2, which is my output, will toggle and stay at its state. Its state is 1. Up to when? up to Q1 reaches at its downward ledge. Again, we'll toggle and stay up to toggle 1, 0. Now, interesting. Look at here. Look at here. Now, if I take it here, now what I wanted to count. Now, how can I count? Look at to this section. At this time, what is my Q0, Q2, Q1, and Q0? All of them is set to 0. Q0, 0, Q1, 0, here is 0, Q2 is 0. Now look at here. What about Q2, Q1, Q0? Bir nefer desin.
1 0 0.
0, 0, 1. What about here? Here?
0 1 0.
0 1 0.
0, 1, 0. And here? 0, 1, 1. Here?
1 0 0.
1, 0, 0. Here?
1 1 0 0.
1 0 1.
1, 0, 1. Here?
1 1
1
0.
1 0.
1, 1, 0. Here?
1 1 1.
1, 1, 1. Here?
0 0 0.
0 0 0.
0, 0, 0. Interesting. Look at here. Exactly 1, 2, 3, 4, 5, 6, 7. After reaching to 7, again I set to 0. If you look at here, again I will start with the 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, up to again reach to 1, 1, again set to 0, 0, 0. Using three toggle flip-flops, I could produce the numbers from 0 to 7.